Welcome. Today we're going to be taking a look at Java 2D arrays and how we can work with them and understand them better. So let's go ahead and get started. 2D array is a data structure, so it has a 2D structure, and we have a data organized into either a 2D grid or matrix is how we often look at it. And in Java, it really is just an array of arrays, and we'll talk more about that as we go through this. We don't have a keyword because, again, it's just like a regular array in Java. There's no actual keyword. We have two sets of square brackets instead because arrays are hipster. And we can either store primitives or objects inside that. And as you can see right here, I have type 2D array variable name equals a new type, passing it the rows and columns to specify that. And rows will always be that first set of square brackets. Columns will be the second set of square brackets when we actually take a look at the 2D array itself. So let's take a look at the representation of a 2D array. Now, because it is an array of arrays, we have some visualization we want to make sure we have it in our head to match what we're talking about for both the code itself as well as the logic attached to it. So a 2D array, in this case, sample array, is the actual structure we're talking about. We can see that it's an array of arrays. We have 0, 1, 2, and 3, the rows of that thing, and then the quote-unquote columns right here of 0, 1, 2, 3, and 0, 0, 1, 2, 3, and 1, 0, 1, 2, 3, and 2, and 0, 1, 2, 3, and 3. That's the actual structure of the array. So it's the array of arrays is a logical structure beyond that. So we have the 2D array. Each row has cells inside that to make that up. And so you can extract rows out as a structure, but not columns. The columns are just individual cells in each individual array itself. And we'll talk more about that as we go through and see some sample questions. Now, when we're talking about the actual addresses or the logical structure of array, one of the nice ways to look at that right here is the idea of, like, say, for example, an egg cart. It's a great way to organize, and you can, like, oh, I can put these things in these different spots. I have the rows that go down, the columns that go across, and I can reference the individual cells inside that and talk about that. And we have the addresses right here. So I have array name sub 0, sub 0, sub 0, sub 1, sub 0, sub 2, sub 0, sub 3, sub 0, sub 4. So the idea that, oh, I've got that row 0 right there, and then inside that I have spots 0, 1, 2, 3, and 4. And then I have row 3 inside it. I have spots 0, 1, 2, 3, and 4 inside that. And so that structure right there, if we go back to this design, we can have the idea that, oh, inside this one, I have these spots. Inside this one, I have these spots. And we use the addressing system like this so we can visualize and understand it logically in our brains up here a lot better as well. So we have the logical idea versus the mental structure we use to keep track of those structures. So that's just something you want to keep in mind as we're working with the idea of 2D arrays. Now, if we want to access elements inside the 2D array, we have to use the row and column address themselves to do so. And so we need the individual row and column themselves to get that. So the assignment operator tells us how we're going to access that. If we're assigning to that spot, the equal sign or the assignment operator is going to be after the array name and then the row column address we're talking to, and then the value that goes inside that, as we see in the assignment line. To retrieve values from an array, we paste a variable that's going to grab that to hold it, type item equals, and then the array name sub row sub col, so we can retrieve those values from that array. And so that's how we can retrieve or assign from the array itself using a 2D array. So there are no methods. Again, it's just a regular, like a regular array. There's nothing it can do on its own. It simply assigns or replaces values. We can access entire rows as well. And so I can get an entire row of the 2D array by the address of that row. So type array items is equal to array name sub row. So I'll take the entire row out of that array, and I have a reference to it now that I can use and reference as a variable with that. Or I can replace a brand new array into that row by saying array name sub row equals new type array name dot length, and it'll put a new empty set of values. Or I can even assign a brand new declared list of arrays inside that as well. So I can simply just put that in there. Now we have this lovely reference right here, and my students created this art for me a while ago, and I have sub0.length to talk about columns, because sub0 is cold, C-O-L, columns, and since my minimum requirement I have for all my variables are 3 letters, so col is the usual abbreviation for columns, and so sub0.length is the columns we have for that. So a nice little reminder on how we can do that. It's a cool little Mortal Kombat reference we can have for class. When we're talking about 2D array initialization, we have to remember that there's a default value that's going to fill every single spot inside that array. If we're talking about primitives other than Boolean, it's going to be 0. Boolean, of course, will be false because that's the default value of a Boolean. And then null, every single object is null as the default value. When we create the array, it's filled with nulls. And we can also initialize values separated by commas, surrounded with squigs themselves to separate each row for that. And we'll see an example of that as we talk the initialization sequence here in just a moment. So here we have those different types of initializations we can see. So we have int array grid as a new int array of 4, 5, so 20 zeros. We take a look at that right here. And so we have our new int array that shows up, and we have the 4 by 5 grid of zeros that fill that up, and we've got that ready to go. We have a debug duck 2D array boring array as a new debug duck, which is 4 by 4, so 16 null values. Oh, sad kitty. And so we have our debug duck 2D array right here, and so I have null, 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 null all the way down for all those values because I initialized it with that empty value object because there's nothing in there yet. We can also initialize an object with existing values. Right here we have a string 2D array words, and we can say these words are in a 2D array of string. And so now we have our words array and initialize each value in that. And so the 0th row, the 1 row, and the 2nd row, initialize those values in each cell inside that separated by the commas. So these words are, that first row, in 2D, the 2nd row, and array of string, array, so word sub 2 is that row right there. So we have a way to take a look at that as well. Now, we often need to iterate over a 2D array, so iteration we're going to use the standard for is our default way to do so. So proper iteration can be done either in row major or column major order, or even any other major order if you're doing for complex stuff like, say, for the AP exam. Generally, though, with row major order, you're doing rows first as the outer loop, and column major is the columns first as the outer loop, and that will do the processing for that. Regardless of the style, you do want to nest loops. It makes life so much easier to actually nest the loops than try and calculate as a weird single for loop. Don't want to do that. If you need the addresses of objects, aka you want to replace values, you have to use the standard for loop because you can only assign values if you have the address. So keep that in mind. So when you're replacing, standard for loop. If you want to iterate backwards or do various steps, you can use your standard for loop to do that. You can go backwards through the array. You can go over just half of the array. You can go every third spot because you just modify the plus equals 3 at the third part of the for loop. All those kind of things you want to do. Great kind of stuff, wonderful things. Get that going. Here's some code to show that standard for loop right here. So I have for int row is 0, row is less than grid.length, row plus plus, and then for int call is 0, call is less than grid sub 0.length, call plus plus, and I'm printing out the values at sub row sub call of that 2D array. I can also have one right here. I'm doing for int row is 0, grid.length, row plus plus, for call is 0, call is less than grid sub 0.length, call plus plus, and I'm assigning into it. So grid sub row sub call is assigned a random number between 0 and 1, 2, 3, 3. I know, it's amazing stuff. When we want to use a for each, though, we can also use a for each very effectively with a 2D array. It's great for outputting values or evaluating values or doing updates on an object. You can't replace values, however, in a for each. There's no assignment. You can't use the equal sign to make any changes to that. Objects that have mutator methods can be called to update that state. So remember, that doesn't include strings because strings are immutable and you can't update a string without replacing it. So no strings, but objects other than that, totally cool to do. Now, the only limitation on that is you have row major order because, again, you can only extract out a row at a time from a 2D array. The columns themselves don't exist as a structure. So here we have the example of that. So for int array row inside grid, for int value in row, and I can print that value out. And then I have for int array row grid, for int value in row, and I have value equals 7. And Eclipse is so nice, it even warns us this is doing nothing because that 7 is assigned to a temporary local variable value that does nothing. So I'm just throwing away 7 into nothing because it doesn't actually change that. And so Eclipse even warns us, the yellow underline of uselessness, that it doesn't work, which is lovely. Can't replace values using a for each. Doesn't work. Okay, so we have another demo for that. So we have a debug duck 2D array named duckburg, and it has a new debug duck array, 5 and 6. And then we go through and iterate over that debug array and add a new debug duck at new row column for adding that value for that parameter for that. And then for debug duck array row in duckburg, so I'm going to go each row out of that 2D array. And for each debug duck that's in current duck in that row, so I'll get out each duck out of that as I talk to it. And as I talk to each duck, I'm going to say, hey, int helpfulness. So I'm going to get a random number of 0 to 12 on that. I'm going to set that current duck's helpfulness in that new value. So I can use the dot operator to modify that set questions count. And I can update the values of that object. And I can also use the dot get name on that current duck to extract the name information out of it to go in the display message for that as well. So I can use the dot operator to mutate my duck objects because it's a regular standard object, it's mutable, so I can change that and I can update the values on that. That doesn't work on primitives because you can't replace values. There's no dot operator access internal state. Bounds checking. Oh my gosh, this is huge. You have to do bounds checking when you're talking about a 2D array. I recommend you always do your bounds checking before you do any logic or modification in that 2D array. You want to make sure you get those bounds checking done before you do anything else. So when you're taking a look at this, remember all row indices have to be greater than or equal to 0 and all array indices have to be less than array name.length. So you always have to check to make sure that the bounds are within that realm as well for the row. Column indices are also greater than or equal to 0 and array name sub 0.length. So both those conditions have to be met because remember on an and, both conditions of the thing have to be true. You want to make sure you do your bounds check before any other logic or access to the 2D array. One of the things I recommend doing is doing your bounds check as its own separate if block, and then inside that nest your next if block, do your logical comparison tests. It's really helpful, and it makes sure you can avoid your array index out of bounds exceptions. Good times there. Now again, 2D arrays are still the hipster of Java because they're just an array really. It's an array of arrays. So there's no methods belong to the type. There's no constructors or parens anywhere in sight. We have two data members-ish because we have array name.length for the number of rows, and then we go inside that array for array name sub 0.length for the number of columns. And so that's the way we have that set up to get the idea of a 2D array for the rows and columns. Keeping that in mind, it's still pretty hipster. Now, there's a special case right here for jagged and ragged arrays. You may not actually see this in your class. A jagged or ragged array is a 2D array that's not rectangular, aka each row has a different number of columns. I'm never going to be using this in my class. You might, however, see it in tests, in questions on the internet, or challenge contests you might do. Traversal loops, however, cannot use arrayName sub 0.length for the test condition because each row has independent row counts, so we can't use that. Instead, we have to use arrayName sub call.length to make sure we're traversing that properly. And so we can see an example right here. So you have a private jagged demo right here. So I have int 2D array jagged as a new int of 5, and then nothing right there. I can't normally do a empty square brackets on that because that's not the way it works. And then jagged sub 0 is assigned a new int array of 5. Sub 1 is assigned a new int of 1. Jagged 2 is assigned a new int of 3. Jagged 3 is assigned a new int array of 2. And jagged 4 is a new int array of 5, which gives us the example over here on the right where I have the addresses listed above 0, 0, 0, 1, 0, 2, and then the next row 1, 0, and the next row 2, 0, 2, 1, 2, 2, etc. And then the values of all these are 0. And so you can easily see how that logically is set up. And so you have to, when you're looking at this, you'd have to make sure that you check on that loop to iterate properly over that, which we'll see here in a second. So if I want to traverse this jagged array, I'm doing the same thing now with a jagged array of debug ducks instead. So I have an array of 4, 1, 1, and then 67 because, hey, why not? And then an array of 2. So I have for int row is 0, row is less than jagged ducks.length, same thing for going over all the rows. Now notice the difference right here. For int call is 0, calls less than jagged ducks sub row.length. Not a big change. I'm using the now dependent variable of row, so my column count will match as I go through that appropriately. And then jagged ducks sub row sub call is assigned a new debug duck with that row column address. Now the for each, however, to extract the values, there's no changes whatsoever because I'm just grabbing a row out and getting each thing out of the row because I don't care about the address. And so for debug duck array row in jagged ducks, for debug duck current duck in row, view.display message, current duck.get name, because I'm just grabbing the same thing for all of them. I don't care what indices it has because the index itself doesn't matter because I'm never referencing it. And so if I'm using a jagged array, if I'm assigning, I have to use a standard for, but if I want to print it out or do display updates, I can simply just use a regular for each for that. I hope this is a good review of how to work with 2D arrays in Java. Cheers, see you next time, have a great day. Bye-bye.